So today we are going to solve a problem which was asked in online assessment of Myntra. So the question goes like this. We are given n processes where the ith process starts at start of I and it finishes at end of I. And a core can handle only one process at a given point of time. So we need to determine the minimum number of cores that are needed to handle all the processes. So if we go to the whiteboard, so these are the processes, these are the three processes which the first process comes at 1 and it ends at 3, and the second process comes at 3 and it ends at 5, and the third process comes at 5 and it finishes at 6. If we plot them on the timeline, so the first process comes at 1 and it finishes at 3, second came at 3 and it finishes at 5, third came at 5 and it finishes at 6. So if we see at time 3 there are two processes getting overlapped, and at time 5 there are two processes getting overlapped. So we need to determine minimum number of cores, which is actually the maximum number of overlap at a given point of time. So a simple solution which comes in my mind is like, for each process we will compare it with every other processes, check whether the execution times are overlapping, and then we will count how many processes are running at the same time. And by doing this with all the processes, we will track the maximum overlap found. So first things which comes in my mind is like how we will determine if the two processes are overlapping. So suppose S1, E1 are the start and end time of first processes, and Sj, Ej are the start and end time of the jth processes. So this is the start S1, this is the E1. So there are multiple cases uh, for the jth processes. It can be either between the start and end time, or the end time is after the end time of the first process, or it can be like this. It can be uh, enduring the first processes, or this can be not overlapping. So basically there are four cases for the overlapping case: this one, this one, this one, not this one, or this one. So if we write the pseudocode of it, it will be like, we will iterate through all the process, and then we will iterate every other process, then we will just create a simple function which will check if the processes are getting overlapped. Send the ith and jth index there. If there, then the current overlap will increase, we will increase the counter, and after the end of first the inner loop, we will just track the maximum value. And before the starting of the inner loop, we will assign the value to 0. So this is the simple solution, but this solution is inefficient because we are running two loops. So the time complexity will be around O of n square. So if we think of the optimized solution, so instead of comparing process with each other, we can track the cores in an in-demand fashion manner. So what is in-demand fashion? So if a new processes come, we will increase the number of cores, and as soon as the processes end, we will decrease the number of cores. So, so by doing this, so we will track what are the maximum number of cores at a given time. So how we can do this? First, let me take input, and we will create a vector of pairs in which we will be inserting events. So what are events? So there are two events here. A start event which denotes core demand increases. So as soon as the processes come, we need to increase one core. And there is one end event which denotes core demand decreases. So as soon as the process is finished, we can remove that core. So we will create one vector of pair event. So the first value of the event vector is it is either the start time or the end time. And the second value can be 0 or 1. So 0 denote it is the start time of a process, and 1 denote it is the end time of the process. So we needed this because we need to determine whether we need to increase a core or decrease a core. So first we will take start time of all the process, uh, event dot pushback 0, and similarly we will take end time of all the process, and here we will do 1. I is less than n, I is less than n, and now we will sort all the events. So how will the event will look like? So before sorting, it will be like 1 comma 0 first value, and then it will be 3 comma 0 second start time, and then 5 comma 0 third start time, and then 3 comma 1 5 comma 1 denotes it is the end time of a process, and 6 comma 1. So after sort operation, the vector will look like 1 comma 0, then 3 comma 0, then 3 comma 1. The first process ends at time 3, then 5 comma 0, then 5 comma 1, and then 6 comma 1. So we will do here like in demand fashion. So as soon as the process, so initial course will be 0, 0. So now a new process come, which is so we will need to increase the core. So here the core become 1. Now we will now the I will be 2, index will be 2. Another process come, we need to increase the core. We will increase it to 2. So now I equal to 3. Processes ends, so we can decrease the number of cores. So here the core will become 1. At I equal 4, another process's start time comes, so we need to increase the core. So the cores will become 2. At I equal 5, a process's end, we can decrease the core. And at I equal to 6, uh, decrease event came, so we can decrease the core. So here it will become 0. So the maximum number of cores at a given point of time was 2. So 2 will be the answer. So now we have sorted the event vector. So we will take two variables, which one is the maximum cores, which will be our answer, and what is the current cores at uh, so at this point of time, what are the current number of cores active. We will iterate through the event vector, event dot size. So here we will check if event of I dot second is 0 or 1. If it is 0, then we need to increase the cores. So here we will increase the current core. Otherwise, we can just decrease it. And we will also take the maximum number of cores. So maximum number of cores is max of maximum cores comma current core. And eventually we will print the maximum core. So if we try to run the program, we need to make it a pair. To give the input. So number of processes are 3, and 1, 3 and 5 are the start time, and 3, 5 and 6 are the end time. So if we try to run the program, yeah, so 2 came. So this was the solution. I submitted the code and it worked perfectly fine. So yeah, so that is a tutorial of the question. So we will meet next time with some other coding question. Okay, thank you. Bye bye. Happy coding.